here? Yeah, no, excellent connection. Well, that's kind of good news. Yeah, okay, I think this is working. Oh, it's only 20. But I'm starting early. Fine, fine. Check the sound.
Yeah, okay.
Yep, that's fine. All right. Well, let's kind of have a quick look at the ZigZag task. Hello. All right, what do I have here? Is that big enough? Mm-mm. Too much, too much, too much. Okay, we are live, hopefully. Let me... Right, this is the live stream of the ZigZag tasks. I have tried and publish one a day for the past week. We are up to 6, I think. I've not done 6 live, so I'd be happy to do 6 first, just to warm up. Yeah, I might start with that. And then, I gotta say, those are kind of like, yeah, those are chunkier than I was hoping for, but I might like skip straight to 10, which has an oop angle, so it's not like ooping the whole thing, but it's implementing an undo stack, or they don't use the word, but spoiler alert, yeah, doing an undo redo stack with a class essentially. But let's start with 6, because why not? Just so I get an easy one to get my head back in the game. I've been doing mostly some R this week and data science and stuff. All right, so original, copy that and paste it. Ooh, no. What have I done? It's just, yeah, whatever. Okay. Yes, rename it ZigZag 6. Okay, just Z6, I guess. ZigZag, yeah, I'm using different names for the ones I do live and the ones I do on the video. So this is task 6, which is about moving the list back, but with a score penalty. So, starting the clock now, I hope I'll remember to stop it. We want an option, right? Offered is the opportunity to move the targets back to the right instead of entering an expression. If we do so, it should be moved along to the right by 1 index, and the score should be reduced by 2. Note that the start of the list should be repopulated by -1, meaning empty spaces at the front, from your point of view, is going to be here. Okay, where's my... I don't know where I'm framed here. Yeah, I need to be here, right? Okay, so the front of the... ridiculous. Right, so we just need to kind of move it back, and but the key thing is that we have an option. So this is in the where we would otherwise enter an expression. So we're looking at, not in the main, that's not this input, it's this input. So if I'm casting it, not casting it, I'm putting it in uppercase just to kind of double check. If it's move, no, in uppercase it's going to be move. Then I'm just going to put a pass in here, just so, yeah, okay. So we need a new method, move targets back, that operates as described. So actually we're going to need to say targets equals move targets back, and then the score. Now the problem I have with the score is that all of this stuff is still going to happen there. So in particular here we kind of update target, which is going to move the target forwards every time. So I might need to have a way of kind of hijacking this. I might put all of this, actually, so leave the print, because I want the print in both cases. But I might actually end up doing else. We can't game over when we're moving back, right? So it's fine if we move all of this into the else branch of users have not said move. So move targets back to the new function. I'm going to put it next to update targets, because to update targets, move the target front. Yeah, this one, the very same. This one. move targets back, it should take the targets, and that's it, right? We just need to kind of like give the target list in and return the target list. So so in the video I've kind of like done it two ways. There's a way that shows that kind of iterating backwards over the list. I'm not sure I want to be bothered with this, but we're going to return targets. So you may remember from the video for task 3, I think, whichever one it was, where we changed this to kind of do just a pop and a append. So if we move them back, we want to pop the end. Yeah, we want to pop the end and add a -1 at the front. So we're going to say target. Remove the last element. Okay, so move back, which means we remove the last element by doing targets pop. And we also then put something at the front, so we can concatenate simply. I think there might be a colon notation. Am I thinking of Haskell? But that we could do it simply with. So we're concatenating list. I want a list of one element that is a -1, a single -1, and do plus targets. I'm going to put a breakpoint here just to check that this is doing what I expect it to do. And return targets. Okay, so I've done this. And here we need to say that targets becomes equal to whatever we get from move targets back, to which we pass targets. And as to the score, okay, let's see what their tests are. Oh, that's too big. Well, no, okay, whatever. Oh, it doesn't say what the score should be. So the main thing here is that nowhere here does it say that you need to have the point to be able to spend them, right? So you can just kind of move back and go into the negative for the score. So we're not worrying about this. What we're worrying about is that, well, I mean, if you had it in the real world, I would check the test case to see what score do they expect to have. Because at the moment, the systematic -1, right, which is slightly defective because we've explained this in a number of our videos, that's just that -1 every time, and if you get a target, it's +2 per target, will not happen if we select move because it's in the else branch. So, you know what, I'm just not going to worry about it too much and go score -2. So depending on which way you want to look at it, you might have ended up with a -1 or -2 or -3. So, and I think, I mean, I can't believe this is just it. But maybe it is. Like super confident. I've not done this in a while. A bit rusty. Yes, that's running. Okay, so let's do the training game. And we clear, let's use the terminology. We clear the. Oh, we clear 2 of them first, and then we move them back. All right. 512 divide 8 gives us 64. Plus 2 give us the 68. That's here. Cool. And then 8 plus 3 minus 2. 8 plus 3 minus 2. I've messed it up because now it's going to be 1 ahead from what I expect. But if I type move, boom, it doesn't crash. Sorry, I did put the breakpoint. So the target is here. Oh, after we've fiddled with it. So we had, I think there's a leading, yeah, it starts on the pipe thing, right? So that's 1, 2 blank ones there. And now after that, I have 1, 2, 3 blank ones. It used to end on 4, 1, 1, 9 in a row. And hello, Nepali man. Oh, am I in the right camera? Yeah, I am, sorry. Hello, let me know if you want some particular tasks looked at. So we had 4, 1, 1, 9, and now we only have 3. So it has moved them back, and that is kind of like remove the last one and added something at the front. So I let it run through. -1. So I had 1, and yeah, I went to a score of -1. I only have 3 of those and not 4 because I've messed up an expression when testing with a star instead of an 8. But otherwise, we're pretty good. They don't tell you about the score, so we are good. Okay, so that's like 8 minutes for task 6. Well, right, fine. Let's have a look at the difference and changes. My original is the base that I select for compare. So you select the base, and I have that 6 that it's saved. Compare with selected. It looks like this. We just have this. Put all of the old logic, one indented into the else branch of this new conditional. We're not doing any input validation. If it's not move, it's just going to get misinterpreted as an expression, and you get penalized -1. So, and it just calls the new method, does the scoring. I don't really need this part in there anymore. And at the bottom right here, little overview, you have this method, remove the last element and add a blank at the front and save that. Close the diff, close the Z, everyone's very happy. All right, okay, let me do 7, fine. No, this was not too bad, to be fair. It was like 8 that I thought was a bit of a... Yeah, no, what is going on there? Like the... Well, no, actually, this one's not too bad. It's 9, that's a very bad one? Yeah, okay. What? Oh, yeah, that 9 is going to be a tricky one. Well, it's going to be for whoever does it. Probably not on this one. Right, let's do task 7. Now, this one I'm going in cold. I've not done it before, so that might take a bit longer. Right, ZigZag task 7. What do we need to do? Correctly identify targets in future expressions. So what they mean by that is that if I clear the 15 here, then I should be given the option to add 15 or 1 or 5 to be used as a later turn. We removing the size limit on numbers allowed, and ooh, if the single digit is so that's kind of, we need to make a special case for this because that's not going to, yeah, I'll take care about this. So we need to be able to add 0, which is good because then you can divide by 0. Right, so implement this, right? Play game and check if user... No, what are you doing? Just going to make some noise with the mic. Check if user evaluation is a target. And numbers allowed. I don't know where we need to modify play game, but definitely this one, right? And then a new method, select value from target. Correct. Yeah, and which part they would like to add to numbers allowed list. To select, that's just select, it doesn't do the add. Yeah, that's fine. So this will return a number. This will have the input. This we know kind of from where you want to do it, and this will return. Yeah, I get a good handle of what's going on. All right, so it's play game, which is like right here. Okay, so let's say I'm putting a valid expression. I pass this test. I convert to an RPN. They're all in numbers allowed, and then we call this. So this is going to, yes, and we need to modify this because we need to return a third argument. Do we? Yes, we need to, yeah, we need to return another argument, which is, and we can probably cheat with each target, because is that a Boolean? Yeah, that's like a Boolean. I mean, we only test it. So this target, which is this thing, this Boolean that starts at false and will stay false if it's not a target, but then becomes true the moment we find one. Because of the way Python evaluates, I mean, you must know this, I'm sure, but let's just kind of recap it real quick. If I want some Python, and if I say if true, print high, fair enough, prints high. But if I say if 0, print high, it doesn't. If I now do if 1, print high, it does. In Python, 0, the empty list, the empty string are all falsy in that if you put them in, if you put them in something that expects a Boolean, typically what's after an if, but that could be within a Boolean expression. So Nepali-man, yes, it guides you to answer the question in the same way the ZigZag tasks does, in that, you know, you've got the conceptual specification here, what the user wants, right? And then you get the technical specification here, so like what the engineer is going to say, all right, we need to architect it like this. So you can find, I'm sure, like the section D must be on the physics and math tutor. I mean, it's debatable. Sorry, I'm interrupting myself now because Ovi's got a question. Well, at the same time, right? So the guidance you'll get is something like this. If you go and look on Physics and Math Tutor must have some, the past papers for section D, you'll see the same thing, and then they'll break down. So in particular, if you need a new method, they will tell you you need a new method. Even I think for like local variables, they won't bother too much. But if you need like a new critical, say, constant or, you know, kind of configuration, global variable and so on, they will tell you. So they will give you some guidance. It's not completely, you know, kind of a just do this type thing. Irvi, I think that's going to depend. So the question, I should read the questions because I think I've turned on the live chat replay, but the Nepali man's question was, do you get guidance as to the task in the exam? And then I've got Irvi's question, which is, what would you recommend someone doing if they're not good at coding for the skeleton program? I think that's going to really depend on how not good at coding you are. Remember, there's a section B is a coding task that's standalone, so there's no skeleton code, and it's typically something like let the user input, you know, a 4-digit number and return something if like the sum of the digits. So it's stuff like that. You get an input. You need to be able to manipulate, you know, just the little things. Maybe every now and then when they throw too complicated a one in the kind of mark scheme and the examiner's remarks, you say, oh, they all fail. So they tend to be kind of nice and like what you'd get if you've done a GCSE where there's a coding element like the EdXL one, that would be like maybe one of the final one or maybe more advanced than that. It's kind of, so if you get limited coding ability, I would probably focus on this, because you don't want to kind of like rule out all coding, because that's like, you know, that's section B and D that are out, so that's already half of paper one, so that's like 20% of the total mark. Also, if you're not good at coding, maybe the project, mind you, the project is mostly about the report, but yeah, 20% of the total mark, that's like as much as the project. So if you go and think about the time you've invested in your project, students tend to be can get really excited and spend a lot of time on it. Think about like that's the same value. After that is kind of what tactical decisions do you want to do, but you could probably focus on, like, you can definitely, you don't have to be good at coding to get, do I have the NEA here? The EAD, I don't have the EAD. But if you have a look at the electronic answers documents, there's like a 5 mark and a 6 mark at the start of section D, and I reckon, yeah, like you don't have to be good at coding to get those. So and because they're likely to be in certain areas of the code, you know, if you kind of keep following and look at small questions in the different areas of the code that tends to be affected, that might be your winner. Or like maybe fixing one of the bugs because the code base's a bit dodgy. I found another bug that's kind of an exploit that allows me to win every time. I should show you that. Okay, task 7. No more questions, we're good. Right, task 7, select value from target. Okay, where was I? We want... Yes, I was explaining true and falsy, right? Because what I want to do is, I'm going to leave it to false, but if it's true, I'm actually going to sense it doesn't become true, it becomes targets count. Like the very... Oh no, because we've got... I might, before we empty it, set it to -1, putting a blank space, I'm going to set it, like put the value inside this, what used to be a Boolean. Whatever, it's not a Boolean anyway. We don't have types, strong typing in Python. And because we don't have strong typing, that means that this if, yeah, I suppose like you're not wrong. I would always recommend to keep practicing, but also where you may have like 2 or 3 more subjects, and that, you know, the closer you get, when you get to this time of the year, sometimes you have to apply a little bit of realpolitik, as Bismarck used to say. Right, anyway, is target will return false if it's not a target, but if it is true, it will return the target itself, which means that this test will still pass because no, 0 can never be a target, so we're fine. But if 0 is a target, this would be quite dodgy. What they might expect you to do is return 3 things. Well, that might be like none if it's false, and if it's the target, you get the target value. Just, whatever. I'm just going to put it in here. So if is target, we're going to remove and fill, and then we are going to do, let's have a quick look at numbers. I'm just, okay, where's line 35? Let's have a look at how fill number works. Okay, so we're going to want to stick it. The only place where there's a limit to the length of numbers, I think, is that 5 here. So if I just make sure, I'll let that generate the numbers normally, and then your bonus number you get from 15, 1 or 5, which is only 1, right? I'm going to stack it at the end after. So we regenerate the number. I've got so many numbers allowed. All right, we fill the numbers, and then I'm going to say, did they give us a name as to how we should call this? We don't have value from target. Target value, I think, is probably a good one. No, target value will be, is target is the value of the target. So I'm going to say number chosen. That becomes equal to, I'm calling this new method, this new function they want us to write, which is select value from target. Yeah, okay, so the OOP thing, lil WB, I'm like the big WB. Okay, lil WB, sorry, I should do the host thing. Okay, right. Ta-da, 2 camera, like I'm some kind of YouTuber. This is not even like a ring, right? It's just like a SAD lightbox. I'm tragic like that. Right. Lil WB is asking, do you think they will ask any questions about including OOP into the skeleton code, or seeing as there's no OOP, might ask an OOP-based question for the 20-minute question? Oh, there's 2 questions in one here. For the 20-minute question, I wish. I mean, the reason why in the previous stream I said, no, you're not going to be asked to rewrite the whole thing in OOP. Definitely not. Because that's way too big, and also you're not changing any functionality, so that's kind of like refactoring, which I explained in one of the videos. You can't test for it, it doesn't work. Someone did it in Python on the wikibooks, and I've not had a look at it, but I'm assuming it's a labor of love. Some people are even more disturbed than I am. But ZigZag task number 10, which I want to be doing probably just after this one, is an OOP task. So you're not likely to, I don't think you can design a 20-minute OOP task. No, I'm willing to stake something on it, right? Because also that standalone task has to remain accessible to thing. And now, if on the ground thing, what you may have is you may be tested on OOP on paper, or you may not be tested on OOP at all, right? The rule at AQA, I heard someone that works at AQA actually once say this, is that they actually need to cover the full spec every 5 years. Which meant that, like, one of the last lessons with my year 13 last year, we did something called Operation Oracle and started a big spreadsheet that we all kind of shared access, and we went looking at all of the past papers and categorized like what was on the papers on what year to try and see what was underrepresented, right, and what would be on this year. I don't know how accurate it was because I never actually got a copy of the question papers for 2024. I think they're probably going to be available on your usual physics, maths, whatever, in September. But like, stay tuned, because I'm doing ZigZag task 10 is an OOP task, which we're going to do in a minute. Okay, I'm back here, number chosen. I'm trying to do like the Twitch streamer thing, like on Ritalin. All right. We have matched a target. We have the value of the target into is target that I'm using both as a boolean to test if we need to kind of do the thing, as well as contain the value. So I'm passing is target. I don't need to pass numbers allowed and return it, because this is just going from the target, which might be 15, to prompting the user, so asking for their input, to choose 1, 5, or 15. And let's put it, is there some input? There's no kind of input function, so here, because why not? Def, select, what did I call it? Select value from target. No worries, lil WB. Select value from target will take the target value, and that's it. Okay. How do I break down? Okay, so this is a good question because it's kind of useful for section B as well. You've got a... Am I in Python? Let's pull up Python shell and make that a little... Actually, I'm going to go bigger and make that the main screen. Right, let's say you have a number like n is equal to 1, 2, 3. Now, if you want to figure out the values of the... the values of, say, so the values of each of the digits, if you do this arithmetically, so the units is the remainder of the division by 10, right? So like it's n modulo percent 10. This is giving you the unit. Now, if you subtract this number, so you do n is equal to n minus 3, you get 120, and now if you do n modulo 100, you're getting 20, which you can figure. So, long story short, it's a pain to do it arithmetically, but if you say s is equal to string, if you cast 1, 2, 3 to a string, and you can do like just s split, and you're not splitting on any character, which means you are splitting every character, and yeah, no, but that's fine then. Okay, S is here. Yeah, change for an hoop question on the skeleton code, and I think something like ZigZag 10 is probably not the worst one. Right, I want to split this into component parts, and I don't want to kind of humiliate myself by having to Google something in front of the stream, so I might just go and Google it on another window. How do I... Are we not doing... Right, I can probably do it as a C for C in S. Bang, list of characters, and then I could like map int onto the list comprehension that I got from the string. And then, yeah, whatever. But the point is that it's simpler to go through via a string. I think probably there's also a simpler way than the one I've done it. Okay, so if target value, if it's smaller than 10, so if it's a one-digit number, I probably need to actually spell my variables correctly. If it's a one-digit number, we are going to we're going to say offer possibles. Possibles is a list made of the digit 0 and then the target value. Right, so if you clear like the number 9, you get the chance to add a 0 in here, which means that now 0 can be in the allowed number, but 0 can never be in the target, so my falsy things works. Else, so else you get the choice of having the number itself, possibles. So I'm initializing possibles with the target value itself. And we're going to add to possibles the decomposition of target value into its component parts, which I'm a bit rusty on this, but cast this to a string. Cast it to a string. Now I've got like 1, 2, 3 in between quotes, and then I'm going to extend. So I'm extending the list of possible with a list comprehended of all of the characters cast to an integer for all the characters in the string. There's no way it's going to work first time, is it? Surely. Right, so I've got my list of possibles, and then I'm going to say choice becomes equal to input let's not make that fancy. You cleared. Okay, F strings, format strings. So format's an old function where you kind of like, you put some placeholders into the string and then you call format and then you pass some values and it builds the string within. Now it's inline, so you cleared %s. I've forgotten how format strings. I've not used them in a year. I've already forgotten they work. Just a quick look to the console, if you will. Okay, F string value equal %s. Yes, it's a pair. Oh yeah, obviously there needs to be in some kind of evaluation context. Okay, yeah, okay, maybe I do need to Google. There's no shame in Googling, as long as, because you can't do it during the exam, but that's fine. All right, okay. F strings. I can't believe I forgot in Python. And also, Python split a string in 2 characters. Okay, I have strings in Python, the concise community way to embed pattern expressions inside string literals. Oh yeah, so it's yeah, no, I'm kind of like, I'm getting myself confused. Yeah, with the curly braces, yeah. Oh, how did I ever forget that? Duh. And then this is saying here, you cast it to a list and you what? No, you're not. Lil WB is asking, will we need to format things correctly, or can we call outputs to the user be a bit unformatted if the actual functionality still works? The latter, right? You're absolutely fine. They're not gonna mark you on exactly, the thing, as long as if you need to display a value to the user, that needs to be in the message, but like, it doesn't need to map character by character. But it's not something that's particularly difficult to kind of imitate exactly how they're asking. Yeah, if I want to do on this, string split doesn't work. We just cast it to a list. Yeah, no, that's as simple as that. Maybe I don't need to. Well, if I cast it to a list, then I can't cast them back to an int. It doesn't matter actually. I don't need to have them as int because at the moment I'm just displaying them to screen. Fine. I'm just gonna do it like this. So it was you cleared target value. Choose a number, the nuclear target value, right? That's very good. You're very happy. Well done, you. So I'm going to print this, and then we're going to ask F string select a number to add. Colon space and then possibles. Now this is a list as integer, which means it doesn't really matter. Actually it does. It's fine. Actually, I don't need to do that. I'm literally gonna cast it to a list. This is gonna give me all of the individual characters. And so we're gonna have the original one, the big one, the multi-digit number, and then each of its digits, because we've extended with a list. Is that right? And then select number to us and we'll list them. Select number to add, put them between brackets, that's nice. Colon space, and then if in choice is in, right, if the user gets it wrong, do I loop around? I could loop around, but I'm not gonna let the user add something that's not theirs. I've not checked the test case, but I feel like we need to be rigorous about this. I can't just type any number and it adds it, right? It needs to be among the choices I was given. So if it's in possibles, then we'll return return none. If the user has not typed a valid number, I'm returning none, meaning that where, okay, so here I've got number chosen. We filled the numbers allowed. I've got the number chosen as an integer, so whether I've cast it to an int, not here, here. Cast it to an int in my new function. Now I can't just test on number chosen because that could be 0. So if I say if number chosen is not none, we are simply going to append. So numbers allowed dot append number chosen. This doesn't cost any points. This, we're just going to add the thing. The rest works as given. The scoring doesn't change. The evaluation doesn't change. Nothing changes. It's just we get given this new choice. I'm not confident, but then I'm not. Might just be humility. Fine. Unbelievable. Well, they're not even trying anymore. Okay, so I had, say, wait, 512 divide 8 plus 2 plus 2. This should take up to 68. We're not quite there yet, are we? I mean, I could probably live with this, right? So if I say 5, nothing changes. Oh, so in training mode, they always get the same ones. All right, let's get out of this. Random game. Okay, now there's a challenge. Right, so here's the hack. When we check that the numbers you enter from your expressions are, in the numbers allowed, this is the second test here. This only test, this will return false if they're outside, but because there's the way it's nested with the test for being a valid number, the valid number is a regular expression that is just basically digits, but also it needs to be lower than the max allowed. All right, which means that it will accept any super large number that's larger than the max as a valid number, which it shouldn't. So for instance, let's say I want to clear 49. Observe. 49 multiply 8 multiply 3 multiply 3 multiply 5 and multiply 9. So I'm going to use all of the numbers, right? So it's like 1, 5, if I get this wrong. This is the first time I'm testing this, so this might be a moment of sad trombone egg on my face, but if I say divide, yeah, it does. So it doesn't do any of the precedence, so it's just kind of no spaces, let's get that right. Divide 8, divide 3, divide 3, divide 5, divide 9. Yeah, cleared 49, look at that. Okay, so let's say I want to add 49. It's repopulated one and give me the extra 49 I have. But now, let's not cheat. So now if I do 49 minus 1, no, it's good. It's quite happy with myself. 49 minus 1, you clear 48. Select a number to add, 48 for 8. Let's see that 4 works. It doesn't. Ah, yes, that's because some of them, I said if the int of the input, the user, the choice is in the list, which is the case for 48, because 48 is there as an integer, this is there as a, use a keyframe, I've got a keyframe error. My stream bitrate is too high, what can I say? It's just how I roll, I don't even, okay. So this is not just a cosmetic issue. I mixed the types in this list and this is biting me back. Okay, fine. So we're not going to do this because this is going to give them as, say I'm going to use it. I'm going to use it as comprehension. I don't see any other option. So casting to an integer all of the characters for each character in the string. Target value is a string. at this point in time, right? Now they're all ins, so we're comparing an in choice in the possible, we're returning the in choice, and this is going to... Fine, you know what, because I've got the brackets from the list, I'm going to remove the brackets from the message. And play it again, Sam. Get random game, hit me. All right. Okay, 7 plus 3, 10 times 4 plus, god damn it. I could like literally just do 4. Oh no, we can't do the 4. We can't do 2. Okay, I can like 4 divide 2. Cool. So that now we've got a 1-digit number which I hadn't tested yet, so we can check we can add the 0. I didn't put the clock for this one, but it's going to be a bit longer for sure. Right, we've cleared the 2. There were 2 of them. I get 2 points. I actually get 3. Fine. And now let's try 2-digit number. Do I want to? Okay, fine. Come on. 50 minus 4, 48. I've got 0. That doesn't help me at all. Doesn't help me at all. Why would they suggest that you can offer the 0? Because like there's no way this 0 could be any use. Ah, mind you, if to do I could do 4 plus 0. Clear 4, but that doesn't really kind of help me get anywhere. Oh, the 0 stayed in. I thought I'd used it. Ooh, maybe 0 don't get cleared from the list because they're zeros, right? So if I can keep adding 0, it's going to get in trouble. 5 plus 0. 0. I get 2 zeros now. Then my list is more and more zeros that are completely useless because they don't get it cleared. Hey, I've not designed this. Right, let me get a 2-digit number. Like, gonna use the calculator trick again. 41 multiply 3 multiply 8 multiply 4. Okay, it's 3936 divide 7 divide 3 divide 8 divide 4. I feel like I've not done the same thing in the calculator. Didn't work. Don't panic. 7 plus 3 times 4. Okay, good. We're back on track. 7 plus 3 times 4. I've broken this completely. Yeah, I'm with you, Lil B. The 0 is completely pointless here. But this, what I understand is that I seem to have broken something else as well, because now I'm doing this as well. Okay, 42 minus 1. 42, right? 6 times... Oh, no, but it's 6 times 7. 6 times 48. Okay, how about like 7 times 8? 48 plus 4 minus 3. Just... It's like the first time I lose in this game. Okay, so I'm not going to put any zeros in there, I was going to be in trouble. 3 minus 1 times 10 clears the 20. What's happening here? This is awkward. You were all here. You all saw it. It was working a minute ago. Okay, at least we kind of on. Okay, I'm taking the 5, not taking any more zeros. We're fine. Why did I mess with this? 3 minus 1, 2. Times 20. Well, no, Lil WB is asking, doesn't the 7 plus 3 times 4 do work because it evaluated 3 times 4 first, which is also what you would think here, right? But like, this is a clean Z7 that comes from the original, in which we don't have the correct order of precedence. We do have the correct order of precedence. That's right. We can't put brackets. Yeah, okay. No, yeah, I'm the one that's that's buggy, not the code. Sorry, yeah, okay, so anything that I can build that needs bracket, I can't do. Because, yeah, I can't do. So let me get a 2-digit number. I can't believe it's taking that long. Okay, 3 multiply 10 minus 10. Cracking. Now I can add the 20. I'm back on track. And I do 20 minus 8. But I can also add any constituent digit in the thing, and I'm getting scored relatively fairly. Yeah, okay. I think I'm calling it. I think that's the task they wanted. Let's compare selected. Right, what did we do? What's this little thing here? So this is the new logic where number, so is target, there's a crucial thing here, well, that's below, but like here, number chosen, we get the number chosen by asking the user based on the target, and if it's a valid one, I've not checked, we checked on the valid one, the very first thing, we append it once we recall to fill the number. In here I've got this little change, yes, in check user input evaluation the target, so that if we match a target, we actually return the value of the target found here into what used to be just a boolean true false to say have we find anything, because and we need to do this of course before we replace the value with a blank slot. And then there's this new function here to pass just one target value and then ask the user amongst the two, or the number itself, its digits. Frankly, the 0, yeah, I don't get it either, but I mean, ZigZag, I think it's probably like the students doing them, because as you start, the task makes sense, they're kind of like well-defined, there's some good tests and so on. As you progress, it just kind of degenerates, and it's like, yeah, that's the vibe coding, right? Let's do the thing. Well, I mean, Lil, that's why you want to get familiar with the training game. So Lil saying he's kind of concerned about it. I am too, right? You're bad at coming up with the expressions and actually play the game, so I feel like I'm wasting time while testing stuff. This is why they have the training mode, so they can have a set known thing. They will give you the expressions. This is why I was frustrated by this, because this is not how AQA would ask you to test it, because then that's dependent on like you basically playing the game, and like being asked to do like mental maths when you're stressed in the middle of an exam is like the worst. So what you will get is something that's like this, right? Start the training game, and then those are the expressions we're testing with, so we don't have to worry about that. But you'll notice this kind of like there's some large numbers. Well, they want to give you options for the testing. Okay, I want to move to the 10 because this is the one that's the most loopy and probably more interesting than, not that I'm scared of like whatever 8 or 9, but let's do 10 because that's super. Yeah, done this, done that, done the other, and no, not here. Said 10, the OOP queue. Okay. Extend object orientation to allow the user to undo previous moves. Now, like those things are not, you could totally have done an undo stack without OOP, right? By the way, it's just that because a stack, it's an object that lends itself. Yeah, you will always be asked to, yeah. Let's say yes to little WB. So yeah, you could totally do an undo stack without having OOP, but object orientation, because it's a stack, allows you to do all of the operations you know and love, which are push, pop, peek, is full, is empty, whatever. So a new class called undo state stores the copies of the state of the game. When they say store, oh, no, wait, okay, yeah, right. So you are doing the undo oopless, you're introducing object orientation, oh, Jesus. Yeah, okay, this is slightly contrived, right? So you're doing, the OOP part is basically making a type, a data type that will contain the state of the game. They're always free. There's only 3 things for the game. So I would have made a dictionary and then have my stack be the object, but if that's the new class, that's the new class. We want some accessors method to be able to access these properties. I don't think we want individual accessors because the state of the game is always the state of the game. Fine, and then new method add to undo stores it accordingly. A new method, and just like this is cray. Yeah, so undo, redo. No, add to undo, which is store the last term, and then store them and undo. Fine, let's get stuck in. It'll all become clear in time. I guess we'll be doing this here, right? Class. Undo state, stores the copies. Yeah, okay. Doesn't hurt anything, and we def its constructor in itself, and it's simply so we store three things, which are the numbers allowed, score, and the last one, targets, and they each become equal to score, get state. I'm going to return them as, you can return flat. I mean, you know, kind of as a, it technically makes a tuple, but without brackets. Just this list of, just like return, yeah, numbers allowed. No, wait. Right, all of your methods need to have the self, so you can access it if they are instance methods, and return the three things, right? Self, numbers allowed, self, score, and self targets. Now, where do we want when prompted, do not undo the last turn? Oh yeah, we prompt the user. Don't you set objective function described? This is not specified to the level of quality that AQA does, but it is tricky to actually specify those well, and you know, I mean, I throw a lot of shade on AQA, but kudos to them for, I mean, it's not trivial. Fine, we're in play game, we want to prompt. Well, when do we want to prompt? Appropriately? Well, that's very helpful, thank you. Okay, so this is when I would kind of like actually here, right? This is the end of, like, this is the end of the game loop of the turn. But we continue, like, when we're playing, kind of like no game over, right? Game over is false. The game not over. Because if I put it here, right? Or sorry, if I put it here, if we're just about to lose, it's gonna, mind you, it's gonna ask you to undo. That's interesting. You could, I mean, maybe you can undo your losing term. Should you be able to? No, you should be able to, I don't know, whatever. Fine, let's put it, it doesn't matter, we can move it later on, right? So like when the to game over. So we are going to prompt, say undo. Undo question mark, y, n. And then if we're not testing for n, but if undo in uppercase, in uppercase you need to call the method, is equal to a big capital Y, then undo the turn. TK, as in this is from old typography, to come, right? For the time being, I'm just kind of doing the general architecture, which means that now where do I want to store the state of the game? Presumably, if we don't undo, so sorry, those are the frames of my game state that going onto a stack. All right, so let's say this is my previous turn, and then what I've just played. If I want to undo it, I need to have it on top of the stack. All right, so if I... It's kind of pointless, so I'd be... Oh, man. Okay, so... Now the... Okay, fine. The state. The state is an empty list. History, undo history. State history. Now I need to put the state history when before the turn, right? So sorry, you need to put the state in the history, kind of push it on top of the stack at the beginning, right? Because otherwise I'm going to land here and I'm going to don't have anything to pop in here. But Jesus, it feels trivial, but it's certainly more complicated than expected. No, I think I can make it work. I'll just put it into the... I don't want to store the state to the history because I'm going to store it in the next iteration. I'm going to need a minute here. Okay, so state history, fine. Let's say here, while not game over, we have all of that stuff. Say, okay, at the beginning, why not, right? So in state history, I will append. I'm going to do this in one line, right? I've got no chill. I'm going to append I don't even know what I've called it, this new class, undo state. A new undo state instance with score, target, numbers allowed, so I can't yet, numbers allowed, score, targets. I think I'll get this highlighted showing. Right, so before the turn happens, the state of the game goes onto the undo history, stack, whatever. Then the turn happens. Actually, I might put this. I've got the right thing because I wanted at the beginning of, I was at the end of the turn, but I wanted the beginning of the thing. So that's why I don't need the game over thing because the game over is no next turn. So at the beginning of every turn, unless it's empty, okay, so if not state history, meaning state history is not empty, right? If not, you can have it, if you want to be more explicit, you can probably write it like this. If state history is not empty, then we have the opportunity to undo. Therefore, I'm going to take all of this, hide this a little bit, and paste it, indent it correctly. Okay. So to undo the turn, I'm going to say previous is equal to, no, actually I'm going to say numbers allowed score and target become equal to, so state history pop is going to remove the last element and return it, and what it's going to return this is going to return this undo state on which I will call get state. Trust me, I'm a software engineer, right? So like this is, you can string methods because it's always like whatever object is returned does this as a dot notation for the thing you're after. Cheesequake, excellent, can I just say excellent handle. Ask, is the best revision for skeleton code just doing the ZigZag questions and understanding the code as well as possible? Yeah, definitely. Like the best, there's no other. I mean, it's, okay, what we're trying to do here is preparing to be able to encounter a completely unknown task and be able to do it quite quickly enough, right? Meaning that there's no other way. It's not that nothing compares. It's like there's no other way than just getting experience onto the code base, and the more you wrangle it, the more something, you may not have done this exact problem, but it will, what you get on the day will remind you enough that something you've done in the past to know, oh, this is where the scoring is done, this is where, you know, this list is repopulated, etc. So it's like practice, but like really a non-trivial amount of practice, and ideally even timed practice. So you've done it once, kind of redo it again, time yourself and so on, because like really time is everything on the day, and knowing when to cut your losses as well if you're kind of getting stuck in and you can't make it work, which is tempting with the frustration to persist, which is something I would commend in many other contexts, but not when you're on time exam, because that's as much time you can invest on something else. So we're getting this, we're popping the last frame, the last element in the state history. That's a undo state object we call get state, which will return the free variables that make up the state of the game, and we set them into the relevant variables, and that should be it, right? We undo the turn. Otherwise, okay, this is how I need to think, right? So if we have something on the stack, we let you pop something from it. Now the question is, I know that I'm going to want to push the state of the game onto the stack. I just don't know if I need to do it every, let's try that one. Yeah, probably need to do it every time, right? So this, state history, append, undo, and target. So the first time, I just put something onto the stack. And that's like the starting stage of the game. Then I do something once, and I'm like, oh, do you want to, if I'm happy with this, I put the next state onto it. If I'm not happy with it, I pop it, but then immediately put it back on, because I still need to be able to undo my next wrong turn, as it were. This can't be that simple, you may think, but let's find out. It's going to break. It's going to break. Well, 3 times 10. No. Okay, if I don't undo, everyone's quite happy, right? So like I'm going to end the state, and 7 plus 4. Undo, yes. I don't know what I'm undoing though, and that didn't work at all because it's clearly 8. So breakpoint time and debugger, it's the worst when it doesn't kind of throw you an error message, but it's like logically does not work. Okay, I feel I want to, move this like here, so we actually see what state we want to undo. And it does mean that if I'm actually undoing, after that, after I have undone, I need to redisplay the state to which I have undone. Okay, let's try it like that now. Uh, 8, 9, 4, 10, 4, 8 plus 2 is 40, 49. 8 plus 2 times 4. No, because I can't do brackets, I don't have brackets. Yes. 4 times 8, 24? No, 4 times 8 is 32. 6 times 4 is, gosh darn it. Eight multiply 10. Multiply 10. I don't have 10. 8 multiply 9. Oh no, 8 plus 2. I know it's just like that's simple. Okay, 8 plus 2. Try to show off. I'm happy. Do not undo. Actually, I'm gonna. Right. So I've not undone, and I've got something else that's gonna help me maybe do 49. Right? 4 times 10 plus 9. Well, I'm probably, let's say I undo this, right? Yes. So the 49 here had disappeared. I say yes. It still has disappeared. The score has been reverted. The numbers haven't. So the score's been reverted. I know why. Yeah. Okay. I got it. So that's clearly why they wouldn't allow. Yeah. The problem is that score is a variable. That's a straight up variable. This points to an address in memory that contains presumably an integer, right? So you say score becomes equal to what we got from the state. We're fine. But numbers allowed in targets are lists. And lists are just pointers to a location in memory that has a list. Meaning that when I thought I was very clever, right, and I stored the state of the game, those do not contain the actual values of the list, but they contain like a reference. So if I cast this to an explicit list, it's going to create a new list and store this, meaning that the state of this is not going to change, it's genuinely going to capture the state of the game. Because if I don't put that list, I've got references to list, and those will have changed in memory, and the state of the game is returning me what it thinks are old value, but it's got the pointers and returns me the latest value. Try it again. This is going to become much clearer when it works. Yeah, I'm going to use the training game because I kind of know some of the formulas. Yeah, I messed it up. So yes, undo. So I was -1, it hadn't wiped anything because I got it wrong. It's just kind of wiped the score. I like the undo method because we never lose. Okay, what did I do wrong? 512 divide 8 plus 2 plus 2, plus 2 plus 2. Yeah, but this is where I need a non-training game to see whether it restores this. But if I say yes, it will restore the list. Let's do it on a non-training game. So random game. So we can check this out. Okay, so time to do some maths. 19. All right, 19. We see it right there. Okay, very happy. 8 plus 2. I couldn't have so many things. So 8 times 3, 24 plus 2, 26. Oh, sorry, 8 times 3 plus 2, right. This, yeah, cool. So this has changed. This the 26 is not at the front anymore, but 49 is inching ever closer. The score has been opened and so on. I say yes. 26 is back, everything is moved back here, and we are back to this list of available number from this one. Phew. All right, not a bad one, but it could be better, right? Because whether I've still got the original as my baseline for compare. Let's have a look at it. Right, I've got this new undo state class, which is really, it's not really, well, I mean, you know, it's got a getter. It's more of a struct than an object, but whatever, right? And then I've got this stack, which I use a straight up Python list in which I kind of do, yeah. Okay, so we can make this a bit better. Let me say, yeah, let's have Z 10.5. That gonna work if I put a dot in the thing? 10.5, 10_5. Right. I can make this even better, right? Because I am using essentially stack methods. This is basically is empty. This pop here is pop, and to push I have this append. So what if I said can I handle this at the, yeah, all right, so this is a class variable, so this variable only exists for the whole of undo state. And similarly I can define class methods, so def at at class, and def is empty. CLS is the equivalent of self for the class, and I can return CLS.history. Is equal to the empty thing, whatever, right? So I can, again, class so it'll always be, this is where I can be a bit clever, right? Because now I know always when I initialize something, when I create one, I push it to the list, and when I return this, I should also pop it, right? So if I actually, no, we can yeah, def store, or like, yeah, store the history with the class, the numbers allowed, the score, and the target. Score, this is going to store the state by appending, so this class variable, class.history, I'm going to append in it a new, so I can call class itself and create, I think, I might be able to do an undo state. Well, let's try if it works, right? I always kind of try and flex and overextend myself. So, and targets, okay. So we create one and we push it in the same method. And here we're gonna have a class, because they were talking about like add a method. Oh yeah, undo last, they wanted a new method undo last turn, but I mean, they're not verifying it. So two undos are displaying that two undos are available. All right, we can have, they don't even, they're testing stuff they don't like us to do, so we're expecting to actually display the whole, I mean, we can probably display, yeah, let's do that. We can like have a class display thing. Is it class method? Class method, yes, it's more like it. It's the decorator. So I have a class method to store, I want a class method to retrieve. And when I retrieve, it's going to return class.history.pop, and from that pop we get state. Trust me on this. And can we display one? Class method. Pull state in class.history. Gosh darn it. Okay, numAl, I'm not tapping this whole thing again. NumAl score targets becomes equal to state get. It doesn't autocomplete because it doesn't know which type those things are. I could do type hinting if you're absolutely precious, but well. and we're going to print on the same line with an F string. No, I'm going to print print them all, and also print an F string with the not normal, the targets actually. Normal is going to be here. And score, and so this is targets. Okay, okay, state history, I don't need that anymore because I can do it straight onto the class, which feels dirty. It's called undo state. Display the undo state. In here, we're not gonna so instead of doing the pop and retrieve, well, this is the one I got from here, right? It's gonna retrieve, yeah. Retrieve, and then to push it is this one. Cool. Okay, I mean, I'm not super confident about this, but just to show you can kind of oop it even more. All right, random game, and nothing works. Yay! Score and target. Well, what do you mean? Oh no, what am I doing? So undo state store, sorry. We don't need to call a new one because that's done in store. And random game. No, I didn't mean targets with, I'm sorry, I didn't mean targets in the plural. I don't know what we're talking about. Python interpreter. 27. Oh, that's because, yeah, I messed it up here. Okay, we're nearly there. Yay! Okay, so I'm thinking like 10 minus 1 sounds like a good place to start. Right, so that's the state of the game, right? We had the whole of this. I should use display, whatever, but you know, and then I've got the previous numbers that were available, which is those ones, right? And the score that used to be 0, and now it's 1. And I can undo yes or no. I'm going to say no and continue. My expression, I need to refer to this here, is 4 plus 2 plus 1. And now I've got my 2 states, etc. But I can only, I don't know if I can undo, what's the point of displaying the full list if I can only undo 1? Also, effectively, it makes the game like easy and big. But something like this, of having, you know, a little bit, you might quite like one new class, maybe, if it's kind of nice and self-contained, and that also uses your data structures that you know and love. But it's true that I suspect there's no OOP in the skeleton code. Does it mean there will be OOP in the questions? It's difficult to find one that will fit, right? Like even something like that, they would have to specify it much more, as we've seen, because like there's so many ways to kind of architecturing it, and this, although it's the one that's the most OOP, I don't know, like it ends up storing a whole bunch of stuff at the class level, which feels a bit icky, especially considering that there's been so many efforts, you know, passing variables back and forth to control scope. So I think that's going to be it for this stream. Let me just kind of do a very smooth fade. That's right, I am faded. that's it. There'll be one maybe next week. I don't know. I'm probably going to be doing some of those as like separate videos. I will. So watch this space. I try to kind of publish as often as possible. And if you want specific tasks in particular, or if you have specific questions, do not hesitate to leave a comment. And I'll try to kind of attend to everything. And as to the one that asked me to like send him a screenshot to task 15, it's like, bro, do it yourself. Like screenshots are not going to help you, but and I was like, well, maybe I want to do it on the stream, and then I had a look at task 15, and yeah, it's not. It's basically serializing the whole state of the game using characters. I mean, in a way, this is kind of what we've done here with that stack and the undo list, but like here, you need to kind of serialize it as installed as in something you can write to a file, so then you can save. So that would be like a 25 mark or something. So. I mean, they get pretty unrealistic the moment you move further down the document, mainly because it's tied to really specify. Well, right, thank you for watching, and